Welcome back to Wickerson Studios. We are going to continue with learning Rhino. I'm just going to type this in with Grasshopper, and actually I think I'm having trouble. There we go. Maybe I'll put this down here. That'll probably be better out of the way over here. Learning Rhino with Grasshopper, and this is the first tier level of my Patreon. But it's a continuation, and this will be a large script as we're going through and learning as much as we can about, let me just take this off for a second, learning as much as we can about the Rhino curve menu item. And we started with point objects to get a basic use of how to organize our script so we can have a similar script. And we've gone through multiple points. We're going to jump into closest point pretty soon. But the model we left with in the first tutorial of this first tier, looking at Rhino through Grasshopper, you realize we ended up with this script that basically could go through a rotation just from its original points. But that's not so interesting, because the one thing we've done with this transformation over here is we've only brought in a single item or a single piece of data, which is the radius of how we want to do that rotation. And just like we were using our range and everything else we were doing for points, let's do the same thing for that radius, and you're going to see how the data structure kind of changes. I'm going to add that to the group, and then I'm basically going to Control Shift unplug this and plug the domain in over here. So our domain becomes a little more parametric as to how we want to open it. And this is the surface we're going to actually play on. And I may use some data visualization tools to make it a little more interesting as we go. But I think that's where our script was when we left off. I had a little bit of tree data in the param viewer and this data to show you what was going on in the panel, the param viewer, and then switching back and forth from the param viewer to the trees to see what data is going on there. And when you start to think about Grasshopper and think about accessing all of these wonderful points and knowing where they are and what you could do with them after that, you end up building these pretty interesting structures that you can change, that you can manipulate, that you can spin, that you can twist in different ways. So that's enough to get finish off where we were, and we're going to continue along with thinking about the next Rhino command, which is literally point objects over here, curve, menu, point objects, closest point. Well, that is one of the most powerful tools I like with curves that's offered through Grasshopper. So let's jump in here and say we basically want to continue our Rhino commands. That's fine. I'm just going to do this so you don't forget what these titles are for the first couple. And we're going to add those to the group and bubble them up. And we are basically going to, instead of multiple point, after doing single point and multiple point, I want to come down here and use the command add to group, curve, closest point. And that basically should make a little sense to you, especially when you get the command, when you get that node up and running. So we can go into the curve menu, analysis, and we could take a look through here and see if we could find curve closest point. But for those that are new, since you know you want to find curve closest point, just start to type it in. And what's nice is it will tell you immediately as we add that to the group. And we can, well, you can just grab these and center them, space them. Should have something pretty nice, except for my Rhino commands is kind of sloppy there. You're going to need a point and you're going to need a curve. And we need a curve, which I'm going to pull from one of these pieces of data that I had before. So I am going to go back up to my transformation right here. I'm going to use this point to actually grab another point from, because we're going to borrow that container. I'm going to grab a container for that point and use that farther down in my algorithm over here. And when I start to do things like this and bring wires back upon themselves, I have a tendency to want to go here and use wire display and hit hidden or faint. The default is you will see the wire. So maybe just to get you in practice of doing that, even though I don't want you to lose sight of where it came from, we'll just put it in the faint. But the problem with that is you're not seeing the data structure. You're not seeing if it's a tree or a list or a single item. So probably for starters, I'm going to go back on that again. We're going to keep it as to where it was. Now, the curves that were coming in, this is actually the point that was coming out of this geometry. And we don't actually, we want to turn that into curves. So these points we actually want to turn into curves the same way we did before. Curve menu, interpolated. Let's plug in the vertices, and we should have those curves going in the directions that we want. Now, that's not the direction we want, but if you remember what we did up here, as we manipulated those curves from this to here, we put in a flip matrix node, which allowed us to take this data, and I wanted to show more specifically what was happening. This will assume this has been simplified, but it's always good to try and simplify your data before using flip matrix. So let's go in here and take a look at what the data structure looks like. And we can do that through our param viewer. You'll see that it comes in, but there's this other node that I've been using. I haven't used yet, but I've used graphed and flattened. But you'll see there's a simplify tree node, which is going to allow me to simplify the tree, put it in. You'll see all those numbers went from 004 back to 00 to just the third path that's actually on there. And if you take a look at the tree, you can kind of count those paths by these rings A, B, C. And so what I'm going to do is watch how that transforms that tree when I plug this in. And you got rid of all those other paths that just zipped right back to that first one. So you're starting to visualize your data structures and learning how to manipulate them. I'm going to use graph tree here, and you'll see that these curves, when I plug them in here, all of a sudden with the graph tree, and hang on a second, what do I have here? I have simplify tree, which is fine. I haven't done what I intended to do from that initial one. I still have to, with this data structure, flip the items from the paths. So I will go back into tree structure. I will use flip matrix, and I will flip those data sources and watch what happens. They switched again. Now it's hard to see the subtlety of what happened because they were so close. 11 branches. I should have a flip on these. Well, because it's the same count, it's still going to read the same, but it's not going to look the same. The param viewer is going to look the same, but the visualization of those curves is going to change. So I'm just going to put that in like that. Downsize this. We don't need to see it all. I may clean it up later, but I'm able to have these curves, which now I'm able to put into a container of the curves. And I can take a look at those. And because this has now become a bit of an algorithm, I'm going to take this, all of this, and I'm going to group it, and I'm actually going to give it a name right here and type in curves, just to keep my documentation going pretty fast. And this is just the beginner kind of mode of how to use Rhino. And those are the curves going in here. This is one that was down here. I'll put the curves in here and add it to group. Or we can collect it all and just hit group. And there's our little algorithm as we go in. And we've made a curve on the surface that we want to reference a bunch of points to those curves. And the points I want to use are single point parameter points. But I want to make this independent of the last script. So let's go back up here and let's borrow this point XYZ plus the script, because I want to reiterate it, and this one. And I'm going to copy and paste and bring that down here, take that point back to here, take these parameters into here, and I can treat these as parameters, and I can take my single point here and do the same structure just to keep things organized. And I'm going awfully slow for how I usually think and work, but I'm trying to make this kind of understandable to people that are starting out for the first time. And there's our point, and there's our curves, and we should be able to take that point, which I've just generated, which is parametric with the right visuals. I can change that from that initial point, and it will find on those curves, on these curves, it will find all the points that are close to that point. And it's a wonderful way to drive a information system on a surface, if you think about it, because the curve is coming from the surface. And so you're not actually, and I've just left the document. There we go. And I've got a little curve menu down here that I was going to use later, but we don't need it. So this curve, as long as I don't mess up and miss this slider, you can see that as I move that point, and let's take that point so we can see it as well. We'll select edit that. That way when I go in and start sliding around that other point, you see where it is moving down and how it's had an influence on that surface. And you have to kind of keep your eye on where you think that object is. I'm going to move that point up in the Z direction, but that shouldn't influence on the curve. It's the XY that's actually manipulating those curves as to where those points are. And keep in mind where those curves are as well. So that's a nice way to get started. And think about it. The only thing I may do now is take my geometry as points and put them in containers, because I'm not doing any transformation. I'm going to grab just going to organize this a little bit. I'm actually going to grab both points in a container. This one has to be the original point, and all the points coming off the curve's closest point. And I should be able to grab those in as geometry over here, and we'll just add them to this group, and we'll separate them a little bit. And what I will do is slide down here. That's the one problem with that. With grouping, you have to be careful where you're selecting, otherwise you're moving the entire group. And I'm going to grab everything in here and slowly move that down. And now I should be able to grab one of these panel tools, shift, grab a param viewer, copy, and copy paste. Now that's a lot of data that we don't need, because you'll see that this point is a single point, nice and easy. So just keep that nice and small. And the param viewer, and let's plug in the points within this curve. And there's our param viewer, and we can add that back to this list as well. Now, am I going to do anything with that data? Probably just a visualization tool, which I'll just do over here. If you consider the points that are coming in, this one and this one, let's just make a little visualization on surface. And since it's a small script, we'll probably get away with just a sphere. Let's plug that sphere in here. And you will not be able to pull out of a panel param viewer the data. You'll have to pull it out of the geometry, which is the point. And you should be able to then do the same for all the other points. And I'm just going to have a little parametric model that I can play with, a little different than my original one. Those are the points. And I'm going to grab the radius as, what do I want to set the radius as? Let me chase it back. We'll give it a number slider, 1.00. We'll put that radius in here, and we will have a I think I'll just do my first equation for those that are new. You can right click on the radius, hit the expression, and then consider x, what was the number coming in, and I'm going to hard code dividing by 2. And that's going to allow me to have smaller spheres that are influenced by a bigger sphere. And that's something to remember. I think I'll make a little note here. group. Yeah, I think this is a good practice for people starting out. Jump in here. I'm going to make this small and say, note the use of expression. I think it's asterisks. And you'll see it right there. It's not really an asterisk, but it's a 5-pointed asterisk. Add to group. And the radius I can take as a parameter and slide back in here and have that one added to my parameters. And I can slide that, well, once again, the same problem. Make sure you select left to right and just grab one of the nodes that's in there and you should be able to move it relative to the other group. So that's a nice beginning, and you've got a nice little script that you can go back to your original one, and as you start to change that point, the parameters of that point, let me think which point is started, it's these ones. Yeah, as I start to change that one, it'll influence that, but the main thing I want to change is that rotation. We'll play those points off of that sphere, so that's kind of nice. Sorry, I unclicked that, but that the actual pi rotation, I should say, not radius, is influencing where those points are, and then you can also influence where those points are affected here. And you get a pretty nice, subtle parametric model to begin. Now, where to continue with this would probably be going down and thinking of marking your ends of those curves. So a nice thing to do is you have all of these curved datas, and if you take a look back in curve, point object, closest point, there's drape points, which I think I stopped because draping points is something that I would do through the drape node, I think, in Rhino, and it's not something that I feel like scripting in Grasshopper. I'm not really wrapping my head around why I would even want to drape points. So closest point or drape points. It's an interesting node when you click it because drag the window over the created object and then it will drop that points down onto it. Not something I'm doing or computationally thinking about in Grasshopper, but the next item is fairly simple. Object points mark start and end of curve. Well, probably going back into here, you would simply go back in, take this, and you would copy it once, and you would copy it twice, and you would call this mark curve start, and we'll just put it in the same position, and we would go here and do mark curve end, and there probably are two nice nodes for doing that. So up in curves, right here, endpoints. It's kind of the same node. And so I'm going to use it for both. These curves I'm going to actually take as another container because I'm going to use it down here. And I'm going to take those items and put them in here. And now you're going to see I have those marked curves on both ends. Let's take this and add it to group. Makes a nice little heart. And I will take that data and plug that both points into points. Here and here. And you can see the power of working Grasshopper. Just slowly, systematically take those geometries up here, add them to that other group. You can clean this up later if it has to be perfect for yourself, but I'm okay with it now. And then I have the data to drive these points. Copy, paste again, and that should give me a way in to check those points on the ends and check those points on the starts. And you don't have to list everything out here in the panel tool to see it because you can use that param viewer to start thinking of the data that you're using. So let's take that. You'll realize we have 11 branches with one item on each, 11 branches with one item on each. And we can add that over to our our panel and param viewer nodes. Now, would I do anything with that? Possibly the exact same thing. We'll grab a half geometry here. Take two of them. They have the expression still on them, and I'm going to just take those endpoints and visualize them here, and that should be enough to start with the visualization as a playground. Now the only thing I want to do is I want to take all of these items and add them over here to that. And we've got some playground items. Grab these last two curves. We also have the curves throughout the middle. We can see how those relate as we play through. So keeping going with this, I'm going to take a little break. We're going to take a look in here at point objects and mark foci. I think I actually will mark foci. And the reason I'm going to do that is because mark foci, which is interesting because it's working within an elliptical pattern. You need an ellipse to do it. I'm going to have to build one to start. Let's see what I could do with that. There's actually a wonderful node for building an ellipse, because whenever I think of a foci, I think about an ellipse. Primitives. How many ways can you make an ellipse? One way here, and take a look at what pops up. The focus of those ellipses. So if we start playing in this, we can mark the foci by a simple node. And we'll just get this done. Take this item, add it to here. Maybe stretch down a little bit. The only thing I want to play off of are a couple of nodes that possibly are higher number values. So I'm going to go in, I'm going to type in 5.99. I'm going to have a radius, and I of course want a different number, otherwise I'll be making a circle. And you can see that now I have a pretty good parametric ellipse. Let's bring these into here. I'm going to pull that over to parameters. Add that to parameters so it's red, and I always know that. This is the function mark foci to actually think about getting at those points. And then of course, because they're points, let's do the exact same thing, and let's mark them with param points. Pretty basic to start to get people up and running and feeling comfortable with what's happening and thinking their way through. These two objects I can pull in here. I can add into my green geometry tab. I can take the two pieces of data, which are very small because there's only two, panel and param viewer. Let's plug the one in. Realize it can be much smaller. Just to keep our scripts kind of nice. Copy paste. Plug in the next one. Take all the items, put them into that grouping. And visualization, I think I'll go back up to this initial one, which had the 1 radii. And we'll copy that twice. And the foci, we can make big spheres like the initial one. This foci and this one. So we may end up driving points from those points later on, but I think we'll possibly just leave it as that. It seems simple enough. Let's just bring this down here. Maybe we'll bring those foci together just because they're working. And a nice little pattern here. There we go. And the parameters for moving that. Make sure you grab just the one you want to move. I think that's pretty good today. Running through and taking a look at a few of those items, thinking how to control your data, how to visualize your data, how to write nice clean script and organized script that with colors and a bit of text. You don't have to write a lot of comments in your script, but you know how you're basically pulling it together. What I'll continue with now are Rhino commands. Going back up into here. We'll come back this evening. I do have a late hockey game with my son. But let's go back up here and say dividing curve by length of segments and number of segments. And if we can get through that, we can go into another section which actually deals with building point clouds, adding points, removing points, which is starting to make you think about lists of items. How do you append? How do you add? How do you remove? How do you reduce? All of these things. And we'll get through all of the lines into our second one. But I have one more section of this initial one that I want to get through with learning Rhino through Grasshopper. Okay, Thanks very much for watching.